Hello everyone, myself Raghavendra Ramachandra. I am from Norwegian University of Science and Technology, Norway. So in this work, we are trying to address the face morphing, especially from the custom 3D face marks. So our idea is to explore whether if we morph two silicone custom face mask, are they vulnerable to the face recognition systems, and what are all the difficulties in detecting such an attack on the face recognition system. So outline of my presentation is as follows. I will start with a very brief introduction on the face recognition system and face morphing, followed by the research contributions. And then in this work, we also present a novel dataset, the face morphing dataset, which is publicly available. I will also present a very brief overview of the dataset, and then I discuss some of the experimental findings of this work. So as we all know that the face biometrics has been widely deployed in various applications that include starting from our smartphone unlocking till border control. So today we are part of the face recognition system by using one or other applications in our everyday lives. So when we consider the application of the face recognition system, especially for the border control scenarios, so we already have more than 800 million e-passports or electronic machine readable travel documents that stores our face image in an electronic chip that will be used during the automatic border control scenarios. So since the face biometrics has been widely deployed in EMRTD applications, so there are many chances that these face recognition systems have been spoofed or fooled using using face morphing technique. So idea of the face morphing is to blend two different face images to come up with a new face image, and this face image in turn can be used to obtain the passport, that in turn can be used to spoof or the fool the automatic border control systems. So the example of the face morphing is as shown in the figure. So we notice that in this particular slide, so two data subject, one is the malicious actor and the other one is an accomplice. So the first step of performing the face morphing is by using the landmarking. Once we have a landmarks, we construct a triangle for each of these landmarks, and then we perform the wrapping operation, and from the wrapping operation we try to blend them using different morphing factors. So depending on the different morphing factors, so we are going to get the face morphing with different weights. For example, 0.3, if you use the 0.3, then the outcome of the morph image will be similar to that of the malicious actor. If it is 0.5, the both are equally weighted. If it is 0.7, then the outcome of the face morphing is more towards the accomplish. So attacker can use any of these weighting factors depending on its application to obtain the passport. Once the passport is obtained, since the morphed images can be fooled for the face recognition system, so then both malicious actor and accomplice can use this passport to fool the automatic border control system. So the main motivation of this work is, since the face morphing has been explored for more than a decade, so now there are several new regulations that are coming up in both European countries and also in several developing countries that requires the live registration for the passport applications. So earlier days, the person who want to make the passport application can carry a printed passport photo with him. So once he is allowed to carry a printed passport photo, obviously there are several opportunities for him to carry a morphed face image such that it can fool both human observer at the passport application and later on at the automatic border control gates. So now with the live capture person needs to go only with the application, and his face image is captured using a kiosk. So under these circumstances, in this work more particularly, we are interested to see if an attacker can go with a custom silicone mask which is morphed between accomplice and malicious. Can it spoof the automatic face recognition systems? So this is the main motivation of this work. So more particularly, we are looking if we can morph two different silicon face mask images, then if we present the morphed mask image to the face recognition system, can it be a vulnerable for the face recognition system? So with this motivation, so we presented four different research questions, and we want to answer these for four different research questions. So most of these all these research questions have been targeted towards towards benchmarking the vulnerability, as well as the detection techniques for the SMAD, as using both the single morph attack detection technique as well as the differential morph attack detection techniques. And more particularly in this work, we also explore the influence of the imaging device. This work is more targeted for the smartphone based applications, where the morphed mask has been captured using three different smartphones, and we try to benchmark several experimental results in the paper. So this is a very brief introduction on the face mask morphing dataset. So due to the unavailability of the morph masking, so we try to do the face morphing in the face silicon mask morphing, especially in the digital domain. That means that we take the digital photography of two different silicon custom face mask, and then we perform the morphing on those on those images, and then we present that morphed mask image to the face recognition system. So that means that the whole experiment has been carried out in the digital domain. So here we can see that in the database it has two different types of face mask. The first one is the human is wearing the face mask, and the second one is the face mask are placed on the holder, such that the eyes are artificially placed. So this will give an comprehensive analysis on both on deciding the vulnerability, like whether if we physically present the mask to the system, whether is it more vulnerable compared to the human wearing the face mask. So in the table we give the statistics of the database. However, the database is available public for the research purpose. So this is the quick results on the vulnerability. So here we show the vulnerability on the left, the different scatter plot for both with the mask morph with artificial eyes, as well as without artificial eyes. So the most of this has comparison score of the face recognition system from with the arc face FRS are clustered towards the right top corner. So if something is clustered on the right top corner, then then the threshold for the both subject 1 as well as the subject 2 has been crossed. That means these systems are highly vulnerable for the custom silicon face mask attack. So on the right we see some of the quantitative results. However, the more results are available in the paper, so therefore I will request people to go to the paper to find the results on both morphing, both the vulnerability as well as in the detection thing. Thank you very much.